Hello Engineering Club! We've got a big day coming up this week, Assembly Day. This week, we are going to have 3.5 hours to turn a bin full of assorted parts and components into a fully functioning robot arm. Now the question is, are we going to be able to do it in that short of an amount of time? And the answer is, I don't know. This is a big project, and actually the biggest project we've ever done as a club together. So this is really going to be a test of how well we can work together as a club. Now luckily, we're not going to be going into this project blind. You see, a few of us over the summer semester looked through all of the assembly instructions for the robot arm and even pre-assembled a few of the different components.
Holes are probably not gonna align. Here we go.
Now the thing is, at the time we didn't have access to the SOS 3D printed parts, and we really wanted to incorporate those into the robot arm for their extra strength and precision. So at the start of this semester, we deconstructed all of the pieces that we had assembled over the summer semester and printed out all of our SOS 3D printed parts to incorporate them back into the final design. Now just because we had to take a step back doesn't mean that we lost everything. What we gained from that was a lot of valuable experience about how to put the robot arm together efficiently. From our experience, we came up with a few different teams in order to streamline the process as much as possible. Team number 1 is going to be our polishing crew. Now, a lot of our non-SOS 3D printed parts come with support structures, which are temporary structures that print onto the actual piece that later need to be removed. So our polishing crew is going to be removing supports like this, peeling off all of these temporary support structures so these parts can be added to the robot arm, as well as also sanding down or filing down any rough edges that are left over after removing the supports. Now the quality of some of the prints is going to vary, so every now and then the polishing team may also have to drill small holes into certain parts in order to make it easier to install bolts and bearings. The polishing process will generally be the easiest process of assembling the robot arm. If you are feeling any kind of apprehension about the idea of doing actual assembly, or if you did do actual assembly and you just want to take a break, the polishing team will be the easiest section. Our second team is the robot base crew. The robot base crew is going to be taking steps 1 through 51 of the assembly process, and is generally going to be the easiest section of the assembly. So the robot base crew is going to be assembling the largest parts of the robot arm, the base of the robot arm with all the big motors and big discs and everything. Now this is going to be a very important team because just about every single piece of the robot arm connects to the base. There are some steps of the arm that cannot be completed until the base crew is finished putting together the full base. Next we have Team 3, the joint crew. The joint crew is going to be handling steps 52 through 64, and they're going to be putting together a large joint for the robot arm. So that's going to involve the second biggest motor, and once it's all done, it's going to attach in a very satisfying way to the base of the robot arm. Next, we're going to be jumping ahead to step 83. So that's going to be the inner robotics gear crew. This team is going to be working with a gearbox for the robot arm, and that gearbox is going to be essential for having the actual grabber arm be able to rotate like a wrist. This team is going to be working with very, very small gears that have been printed from the SOS 3D printer. These are going to be very satisfying to put together because these gears are very, very precisely printed. So they fit together just so smoothly and in a very satisfying way. If you want to work with these gears, this is a good team for you. Team 5 is also going to be working with gears, the fine gear crew. So this team is going to be working with slightly larger types of gears called bevel gears. And this is step 100 through 141. So these are some of the steps towards the very end of the assembly. Lastly, we have Team 6, the hand crew. This crew is going to really be working with the very end of the assembly, 210 through 240. So those steps are putting together the actual pincher claw for the robot arm that is later going to be installed into the robot arm once it's all put together. So if you are part of the hand crew, you are going to be making that grabber, and at the very end, once everyone's parts are all connected together, you are going to be the final group that puts the hand into place and finishes off the robot arm. Now you may have noticed I've skipped over a couple of steps, and that is because these teams were selected by very carefully looking through all of the instructions for the robot arm and picking out which different sections can be assembled without having to rely on any of the other sections. Once all these different separate sections are complete, then we can do some of those middle steps of attaching them all together. Now, depending on how much time we have, we may also try a little bit of wiring, and wiring all of the different motors into the motor shield and the Arduino. And depending on how much time we have, this is really iffy at this point, but we may even be able to do a little bit of motor testing, just to make sure that all of the motors are properly secured into place, and see if they actually move the robot arm in the way we want them to. Oh, and also, since this is going to be a very big day, we're going to absolutely be bringing snacks and drinks, and we may even bring pizza. No promises on that last one though. That's all for this video. In the next one, we're going to be looking at the next steps starting phase 2 of the robot arm project, and also getting started on some BattleBots.